This video describes the functionality of a Levee Digital Twin. The Digital Twin was developed through a University of California at Berkeley project. The project was funded by Yuba Water District. Powered by easy digital twins, it is an interactive platform for data archiving, inspecting, and monitoring levees. In this walkthrough, we'll cover the functionality of the platform, navigating the map, working with data layers, monitoring live sensors, exploring 3D point clouds, and taking measurements. Let's dive in. When you first open the platform, you'll see the cover page. From here, you can read about the project and review the acknowledgements in the top right. You'll also find a user guide button that opens the full written manual and a tutorial button that launches a quick guided tour inside the platform. Both are there whenever you need a refresher. To begin, click Enter Platform. The platform covers two sites, which were the focus of the study, RD 784 and Dry Creek. To load a site, click its symbol on the map or use the site selector at the top. We'll use RD 784. Once a site is loaded, here's the layout. Across the top is the top bar with the site selector and viewport controls, and the user guide and tutorial buttons are up here too. On the left is the main panel with 4 tabs: Layers, Properties, Live, and Alerts. And filling the screen is the map itself. Let's move around. In the 2D view, click and drag to pan and scroll to zoom, or use the plus and minus buttons at the bottom left. Underneath is the background map selection. You can switch it between street, topo, and satellite, depending on which base map you want your data to refer to. As you move the cursor, look at the coordinate readout at the bottom center of the map. It shows your cursor's location, which you can read in either geographic or UTM coordinates. Right here in the 2D view, there's also a 3D terrain button. Turn it on, and your layers drape over the real elevation of the ground, so when you orbit the camera, the whole scene takes on the true shape of the terrain. If you're ever unsure how to move around, the Navigation Controls button opens a quick explainer of the mouse controls for the view you're in. Now the viewport buttons at the top switch how you see the data. 2D is the flat map. 3D gives you a full perspective view with real 3D terrain and objects. H and V split the screen to show both at once, and Picture-in-Picture puts a small 3D inset over the map. Let's switch to 3D. Now you can drag to orbit and tilt, and scroll to zoom in and out. And if you ever get lost, Reset View brings you back. Now the heart of the platform, the data layers. Open the Layers tab. The layers are grouped by type: photos, raster, vector, subsurface, point clouds, and live sensors. Click a group to expand it. Each layer has a checkbox to show or hide it, and clicking a layer's name zooms straight to it. Let's start with rasters, the aerial imagery. Turn on the multispectral layer and the thermal layer. A useful trick: open more than one at once and adjust their opacity to blend or compare them. For example, fading the thermal layer over the multispectral to see how they line up. The Photos layer holds geolocated field photographs, each one pinned to the exact spot on the levee where it was taken, and also shows the orientation of the photo, so you can click a photo marker on the map and see conditions on the ground at that location. The subsurface group is where the platform really stands out. This is the data beneath the surface. There's EM resistivity as both a mapped layer, the highest ppm readings, and as a full 3D point cloud of the subsurface. There are boreholes, and when you select one, the Properties tab shows its stratigraphy, the layered soil profile at depth. This is how you see the hidden structure of the levee. A few layers, like boreholes and piezometers, have a Labels checkbox, which turns on text labels so you can identify each feature at a glance. The Digital Twin platform also allows the visualization of the output of AI-based techniques with the goal to assess the health of the levee. In this case, for example, a convolutional neural network, or CNN, was developed by the UC Berkeley group to detect animal burrows. These are important to detect because these burrows result in levee deterioration. The neural network can be run on the platform itself, But in this case, we only show the output of the CNN. You can see the output of the model by opening the vector group and enabling the burrows layers. Overlay both dates, January 2025 and February 2025, with the multispectral and thermal rasters to check the propagation of the phenomena and the accuracy of the output. Now, point clouds behave differently depending on the view. In 2D, opening a point cloud shows a footprint polygon, an outline of the area the cloud covers, with a label inside it. Click that label to open the cloud in the 3D viewer. In 3D, the actual point cloud appears in place, and you can adjust its point size. There's also a button on the layer to switch to 3D and fly straight to it. One note on downloads. The data download buttons are currently available by request only. Hovering one shows that message. Point clouds are dense 3D scans of the levee. To explore one in detail, click Open in 3D Viewer on a point cloud layer, or click on its label at the 2D view. The viewer has a built-in guided tour. The Start the Guided Tour button walks you through every tool, and hovering any control shows what it does. The Point Clouds panel lists the clouds for this site. Use the checkbox to load or unload a cloud, and the eye icon to show or hide it. You can load more than one at once. Here's the surface photogrammetry, and here's the subsurface resistivity beneath it. To navigate, click the Navigation Controls button to see the mouse bindings. In Earth mode, left drag pans and right drag rotates. In orbit mode, it's reversed. Under Appearance, EDL adds depth shading, and Color By lets you color the points, by elevation, intensity, classification, and more. Now the measurement tools. You can measure distances, heights, areas, and angles directly on the cloud. The Height Profile tool is especially powerful, and it's where loading two clouds together really pays off. Let's load the January 2025 photogrammetry, the surface, together with the EM resistivity point cloud, the subsurface. Now draw a profile line. Click points across the levee and right-click to finish. A cross-section window opens, and because both clouds are visible, you see them together in section, the ground surface on top and the subsurface resistivity directly beneath it in the same slice. That's a powerful way to understand what's happening below a given line across the levee. Any cloud you've set to show appears in the cross-section. The Volume tool measures cut and fill. Draw a polygon over a surface, and it reports the volumes within it. And the Clip tool isolates a region of the cloud so you can focus on just one area. Back on the main map, you can also take quick measurements. Pick the Distance or Area tool and click points on the map. Distances show in both metric and feet. There's also a Point tool. Click anywhere on the map and read that location's coordinates in either geographic or UTM. And when you want to save what you're looking at, open the Export tool to create a quick map layout. Give it a title and choose Export PNG for an image or Export PDF for a document. This captures your current map view, so set it up the way you want before exporting. The digital twin is not just about past data, but also current data that is collected by sensors. The Live tab shows near real-time data from the field. It has two sections, cameras and sensors. Under Sensors, each piezometer's readings are plotted over time. Use the range buttons, 24 hours, 7 days, 30 days, 1 year, or all, to choose how far back to look, or set a custom range with the date pickers. The chart shows pore pressure, groundwater level, and temperature. Switch from Single to Compare to overlay both sensors. Then use the Pressure, Level, and Temperature tabs to compare one measurement at a time. You can expand the chart for a closer look. On the map, each sensor is colored by status: normal, warning, alert, offline, or no data. If a sensor stops reporting, you'll also see a notification in the Alerts tab. Now the cameras section. These aren't just photographs. Each camera is mounted at a fixed location on the levee, continuously monitoring the condition of that section and the water level right there. So, you're watching a specific, important point on the levee over time. Pick a date and an hour, and step through the images with the previous, play, and next controls. The first button jumps to the earliest available photo, and latest scans back from today to find the most recent one on file. And the Maximize button opens the camera view in full screen, so you can study the levee condition in detail. That's the tour. You now know how to navigate the platform, work with layers, monitor live sensors, explore 3D point clouds, and take measurements. For more detail on any feature, open the full user guide from the platform, and you can always revisit this video. Note also that the UC Digital Twins platform does not restrict the data that is being hosted, but it is expandable to additional datasets. In this case, this digital twin includes data that was collected as part of the University of California, Berkeley research project funded by Yuba Water. And it's built on UC Digital Twins, the platform that makes geospatial digital twins like this one possible. Thanks for watching.